Hello, my name is Gary, and welcome to my first video. Why would I want to make a video? I mean, after all, I work at a desk job, just have a small home shop, and there are a lot of excellent videos out on the market. Keith Fenner has a very inspiring set of videos. There are a number of others, Tubal Cain, Double Boost, etc. So what do I have to add? Well, you'll learn a lot by watching Keith's videos and videos from the others, but I acquired a new machine a couple weeks ago. Actually, it's not a new machine, it's a very old machine. And although it may not be practical in today's sense for a modern manufacturing environment, it does have some historical interest, and I need to learn how to use this machine. So I'm going to give you the opportunity of watching me learn and letting me get used to the machine. This is my new metal planer. It arrived on a snowy day about a week and a half ago, and since that time I've gone over the machine, tried to familiarize myself with some of the workings, clean it up just a little bit. Clearly it has some wear on it. It definitely needs a new paint job. I don't have a manual for the machine, and I can't find a serial number or a date on it. But looking in Cope's book on American Planers, Shaper, and Slaughter Builders, I would say this machine was made about 1900, give or take 1 or 2 years. It was made by the G.A. Gray Company in Cincinnati, Ohio. It was originally designed for overhead line shaft drive, and at some point later somebody added this structure in back to support an electric motor to drive a jack shaft and drive the belt. The motor has a nameplate on it that has several patent dates. The latest is 1913. So I'm guessing, but I would say the motor assembly was added perhaps 1915, 1920, somewhere in that range. Certainly a long time ago. The bolts are square-headed bolts, which are no longer common. After test running it, I got a little bit nervous about my shop apron and these belt drives, so I built this temporary shield. It is attached to the motor support assembly, but I did not want to drill into the planer itself, modify the original machine, because someday I may actually put an overhead line shaft in and restore this to its original function. So I don't want to do any more damage than I have to this machine. This is my project. I have this old piece of what I call junk steel, probably something like just A36, something like that. And I got this a number of years ago. I've been using some of these pieces for just miscellaneous blocks around the shop. What I'm going to do with this piece is eventually use it as a riser block so that I can mount a super spacer or a dividing head on my 20-inch G&E metal shaper. A number of years ago I rough finished this on the shaper, and what I want to do now is to smooth both sides, do some finish paint. I may have to do some roughing on this. I can see just looking at it that this is warped, so it's not going to sit on the table flat. But I'll start it out this way. And the reason for this is that if I flip it over, it rocks back and forth a little bit. So we need to find a way to clamp this to the table. I have my workpiece sitting on the planer table, and I'm going to take surface gauge and just check first of all to see basically how flat it is. As I move around, okay, this side's a little thicker, but looking at the point, I'd say it's only by a few thousandths of an inch. So right now this is fairly plain. I'm going to be taking a thin cut. I think with the finish that I did on here with the shaper a few years ago that I've got it reasonably smooth, I've got it reasonably flat, so my finish cut is going to be a very thin cut, a few thousandths of an inch. I'm going to be using a tool that's worked very well for me on the shaper. Now I have to decide how to clamp this. I don't want any clamps sitting above the work. It'll just get in the way of the tool. So I've got to clamp it low. And because of the width of this, if I center it between the T-slots, I don't have a lot of room to get my clamps in there. So I'm going to take and put some posts in on the side, push it over, and I'm going to put some posts up at the end to take the thrust. So what's going to happen is the table's going to move this way under the tool head. The tool is going to be pushing along here, and I know that the shear tool that I'm using is going to be angled and it's going to be pushing the plate this way, which is the reason I decided to put posts on this side. I put 2 in. If I put 3 in, I might get a rocking motion between them, so I'm only going to stick with 2. But up at this end, I'm not too worried about. Now for clamps, I've got a couple low toe clamps. I'm going to put them opposite the posts. And as I put them in and slide them down the slots, I'll raise them up slightly to start. Okay, the work is already tight. These clamps, and tighten them down, and they exert a downward force. So I get these in nice and tight, so this should have no tendency to lift. Now that I have the work clamped, I need to think about what tools I want to use before I can set the machine up properly to use them. One option is to use a shaper or planer tool holder in a small bit. It's not a bad choice. These are very rugged, well made. They're very similar to the old lantern type lathe tool holders, except on a planer or a shaper the tool comes out much straighter than it does on a lathe tool holder. Another option is an adjustable tool holder. This will sit in. It has the advantage that the tool can be rotated. A planer produces flat surfaces, but they don't have to be level surfaces. They could be dovetails, they could be the edge of the work, they could be any angles coming in like this. So this tool allows a lot of flexibility for that. There's special tools. This is the gooseneck tool. I have a form tool on it at the moment. And the advantage here is that if the tool starts to dig in, it flexes up at the gooseneck and that swings the tool out of the work. Special tool for doing keyways, internal keyways, essentially a boring bar mounted into a tool holder. And then I have some large planer tool holders. This one uses a special bit. It's probably a little bit too large for this machine, but it's very, very close. My preference, basically due to my preference with shapers, is to not use a tool holder when I don't need one and just use a bit directly. So this is a tool that has been designed for roughing. And then I have a finishing tool. And this is the tool that I'm going to be using today. And this will mount directly into the tool holder on the clapper box. And once I have this mounted, I can then proceed to set the machine up to make my cuts. This tool bit is ground for a shearing cut, and this produces a very good finish on steel. So I'm going to bolt it into place directly in the clapper box, and I'm going to limit the amount that it hangs below by to about an inch. And clamp it in place. And just to make sure the block is square, get the tool vertical. That looks good, and that feels good. Now adjust the tool slide, and I like to have it just about even with the bottom. So I get it as low as I go without losing any engagement in the dovetail. Now I think it's time to adjust the elevation of the cross slide. There are two bolts back here that need to be loosened. When I got the planer, the one that I'm working on right now was actually broken off, and I had to drill it out and retap the hole and then make a new bolt. That is a little easier to get to. And then I can now use the raising and lowering attachment to get this to the right height. Now my work's about 1.5 inches thick. This is hanging down about 1 inch, so maybe 3 inches up would be about right. So what I'm going to do is set a couple of my scrap 1, 2, 3 blocks underneath here, kind of cover it, and then lower this. Don't need that anymore. The clicking noise you heard is because the miter gears have some broken teeth. There are 5 teeth missing here and a 6th tooth, 1 tooth over. This is the worst gear of the 4. This one is in fairly good shape. Over here, this gear is missing part of a tooth, and parts of 2 teeth are missing here. What surprises me is that this gear actually engages and turns here when you get to the missing teeth. There is enough left of the root and the base of the teeth here for engagement, but obviously at some point I need to make a new gear to go here or buy a new gear. That might make an interesting video in itself. I have to put it low. So this side is about a 10,000th of an inch high. Back to 0. Running back and forth a few times, I'm within 0.5 across the entire width of the table. That's good enough for me. The table has way oilers in the ways underneath. I can see 2 of them back here, and I can see that they have oil in them. Filled those the other day. 2 more under here, and the easiest way to get to them is to move the table out of the way without powering everything up. Just fine by standing on the spokes of the wheel, I can slide the table down. Let's say, what happens if the motor starts? 3-phase is turned off. I don't hear the phase converter running. And the switch is off, so I've got double interruption of power. We should see in a moment. Right here, the oilers, and both of them have oil in them. Notice this also shows that I have clearance under the tool and under the cross slide. Starts my cut. Put the tool about here, and it will reciprocate. On each reciprocation, it will move over this direction. Now to set the table stroke, I have 2 reversing dogs, This one's original, this one's fabricated later. I don't like it, it doesn't look good. Someday, perhaps I'll make one that looks a little bit better. Now I want the table, right now I have the tool bit lined up with the end of the work, and I want about another 6 inches. As the table is moving this direction on the return stroke, this edge hits this lever and causes the arm to reverse to the other direction. So this is about even with the tool bit. I want about 6 more inches. So I'm going to set this dog here. Tighten it in place. And for the other dog, I will go about same distance on the other side. I'll show you in a little while exactly how this whole reversing mechanism works. Well, that was unfortunate. Dog broke in half, and it looks like a fresh break over the bottom half, but the top portion has got oil in it. So the crack would have started right at this 90-degree corner and been working out. And I didn't tighten that tightly, but it was just enough. 100-plus-year-old cast iron. Knows how good the metallurgy was back then. So I need to make another dog before I can use the machine. So I think we have a minor distraction. This project is suspended for today.